Since we can count on the storage account and tables within a storage account having a RESTful API, we can start using some of the other tools that are common amongst RESTful APIs. And you'll probably remember a nice little standard that Microsoft came up with back in the day, and you probably used it with various APIs such as Netflix. And that's the OData protocol, and it allowed you to extend the behavior of a RESTful API. See, one of the issues is with a HTTP GET request, if it's truly a standard API, you can either get all items or get one item. That's useless. Do you always want everything, or do you always want one item? And with storage tables, you have to remember getting all items is very scary, because now you're querying across partitions, and that's going to be a very non-performant query. So what the storage team introduced was OData protocol support that allowed you to implement filters and to be able to filter on specific things. Maybe you want to filter on a partition key, so you only get entities within a similar partition. Again, a more performant query. Maybe you only want to select certain properties back. Again, with any type of web application, any type of data you send across the wire is valuable. So if you're sending massive collections of key value pairs, so every entity has, I don't know, 30 key value pairs, and you're sending hundreds of thousands of entities across the wire, it gets very expensive when you only really need one key value pair. So select statements, and even if you're just doing any type of pagination, issuing a top statement was available to you, so you can do that. So what we're going to look at is some of the URIs and the OData protocol support available in storage account tables. So let's start from the top. We have the very basic get everything. So it's products, and one of the things I do want to point out is that you have this open close parentheses. Think of it like a method in a programming language where you don't pass any parameters. So the default implementation of this method allows you to return all products. However, if you want to just get a certain amount of entities, maybe you just want to get the top 4 entities, you start using these OData query parameters. See, one of the interesting things about OData is that it's implemented using things that any browser or any HTTP client will understand, which is query string parameters. So they have a special annotation, which is the $, and then the name of the parameter. And so we're going to look at the 3 basic ones: select, top, and filter, and how they're used with storage account tables to filter down your result set. So let's go back to this example where we're using the top filter, which is $top, and we're saying we want the top 4 entities, and it's going to return just that, the top 4 entities. If we want to get a little bit more complex, we can say we want only the entities where a certain property meets a condition. And the way we do that is with the filter parameter. Now, we say we want age to be greater than 30, so we'll say age greater than, or GT, 30. Now you'll notice this extra text here, %20, that's just URL encoding spaces, as spaces aren't really valid in a URL. You have to encode them. And you can use any URL encoder to determine this. It's available in almost every programming language. You can even use tools like a Google and Bing, and it'll look up URL encoder or decoder, and you'll get an answer. But essentially, a space is %20. So the actual OData filter is really age space GT 30, or age greater than 30. And you'll see that it returns a result set of entities that matches this condition. You can get a little bit more sophisticated with this. Maybe you want to, instead of doing greater than, less than, maybe you have a string value, you want to do a quality on a string value, a numeric value, or a Boolean value. Instead of doing the equal sign, we use EQ. So OData has its own protocol syntax for equals, greater than, less than, and it's not the operators like you expect. It's actually GT, LE, EQ, and all of this can be looked up if you actually look up the OData protocol, and it's also available in the material in this course. You can use these parameters and filters to do a combination of things, and it's not just one filter at a time. You can do AND statements. You can do more complex filtering. This becomes useful if you're doing some type of solution where people want to drill down into results. So maybe they want to start by getting items that where it's a certain department, and then maybe items where the annual earnings is over a certain amount. You're appending filters onto an existing query. And with OData, you can do this all within the query string. So here we have department, EQ, construction. Notice the single parentheses here for telling OData that this is a string. And again, you'll get a filtered result set. Now you can combine different queries together. So here we used our department EQ construction query again, but we only want the top 2 results from that result set. So we might say, we can filter on one parameter and then combine other OData query parameters. When is this useful? Well, let's say you have 200 entities in your table, and you say, get all the entities where department equals human resources, and you get 60 entities back. So a 200-person company, 60 people in HR, that's a pretty interesting company, right? And you'll have a page with 60 results on it. But you'll notice that many people don't actually like scrolling, they like pagination. And so you'll say, well, we only want 10 results at a time. So now you're getting the top 10 results based on the human resources. So you essentially combine the human resources filter with a top equals 10 parameter. So combining the filters can do interesting things in OData queries. And using the OData protocol, even though not every parameter is supported, using OData protocol, we can do interesting things. We can combine queries. We can drill down into our entities within a partition. We can even go and say filter based on row key and partition key. Again, filtering on a partition key, whereas filter equals partition key, EQ, and then whatever your partition key string is. That's a very important one if you want to make sure you have performant queries, or else you're querying across all your partitions. Again, cross-partition queries are expensive. One more filter I do want to show you is the projection. So again, I mentioned this before, but sometimes you want to get entities back, but you don't want everything. So in this example, and it's a simple example admittedly, we have our entity that has row key, partition key, room, hash coffee, hash projector, and capacity. All is keys within key value pairs that all have their own values. Now, if we want to return these entities, maybe we want to project and simplify this. The only thing we need on this web page is just the room and the capacity. We don't need to know whether it has coffee or whether it has projector. We don't need that information. And you may say, well, this is a simple example, but all you have to do is extrapolate this example out. So maybe this entity, instead of having 78 key value pairs, it has 67 key value pairs. Maybe you're returning thousands of entities instead of maybe one entity. All of a sudden, it's exponential, the amount of savings you get by projecting to just the properties you need. And maybe you're filtering on a partition key. So do you really need the partition key returned in a result set? Maybe you just need the row key and a couple other properties. So using the select parameter, we can do filtering or projection so that we only get certain key value pairs back from our key value based NoSQL store. So using a combination of OData filters, we can do some really interesting things with this key value NoSQL database.